started. Few questions from Coulomb's law are still left. Then we'll discuss some questions on electric field as well. Random questions, random topics. MCQs are left now, no? So whatever classes are left now, we'll practice MCQs only. So till here we did it. Some more questions are there. Try this one first. Two similar, equally charged identical metal spheres, A and B, repel each other with a force of 2 into 10 to the power minus 5 Newton. A third identical uncharged sphere, C, is touched to A. Then it is placed at the midpoint between A and B. You have to calculate the net electrostatic force on C. Try this. This is a question from 2003. Whichever option you're getting, just text me the option name on the chat group. Whether it's A, B, C, D, whichever one. Fine. Try it yourself. This is an easy question. Just be careful with the calculations when the charges are touched. This is based on conduction. Remember, we studied conduction, additive property, charging by friction, charging by conduction, and charging by induction. 3 methods of charging. This is related to that, but utilizes Coulomb's law. Two similarly equally charged identical metal sphere A and B repel each other with a force of 2 into 10 to the power minus 5 Newton. So see, if two balls are there, they are having charges. Both the balls are having charges Q and Q. Both are having the identical charge QQ. So force will become equal to KQ square by R square if the separation between them is R. So force will become R square. So this will be along AC and the value will be equal to 2 into 10 to the power minus 5 Newton as stated in the question. Next, if uncharged C, this touches A. So this will become half. This will also become half. Hamza, direction is not correct. Direction is wrong. So now when the force will come, this will become K, Q by 2 and Q by 2 whole square. So that will make it Q by 2 whole square divided by, again, now see, distance is also getting reduced. When both of them are identical and the separation between them is also getting half. So here what will happen? R by 2 whole square. So you will get KQ square by R square along AC. This is KQ square by R square along AC. This is what you will get. Now see, if we take out the force on C due to B, that will be K. C's charge is Q by 2 and charge on B is Q divided by the entire R by 2 whole square. So you are left with 2K Q square by R square. This is along BC. So along AC, if this is force on C due to A, if this is force on C due to A, I'll write it as FCA. So you have FCB and FCA. So how will you get the net force? Subtract both of these. So net force will be equal to 2KQ square by R square minus KQ square by R square. You will just get KQ square by R square, which is equal to 2 into 10 to the power minus 5 Newton. But direction, see which one is greater, along AC1 is greater or along BC1? 2KQ square by R square is greater than KQ square by R square. This is double of it. So this direction will be along BC. Did you understand, Hamza? Why will it not be along AC? Because this is of lesser magnitude. Okay, good. Now note down the solution. We'll see some more questions. Two small spheres, each having mass m kg and charge q coulomb, are suspended from a point by insulating threads, each L meter long, but of negligible mass. Fine. Now theta is the angle each thread makes with the vertical. When equilibrium has attained, you have to find out value of q square. So by looking at it, you can easily figure out you have to apply Coulomb's law. So this is something like, this is the fixed supporting end. This is the charge q. Let's say this is the vertical, this is theta, this is theta. Fine. And separation between them is also something. Let's say this is A, this is B, this is C, this point is O. Fine, I have named certain points. Now, what all forces will act? Here along the string, tension will act, downwards, mg will act, and in this towards the side, the electrostatic force will act, right? Length is given as L. This much of information you have from the question. Now see, force's value is kq squared, k small q I'll take because I have mentioned the charge as small q. So k small q square divided by this entire AB whole square, I'll put it, right? Now, as the forces are in equilibrium, the three forces on sphere can be represented as three sides of the triangle taken in same order. So if you take the ratio of the force by the side, so that becomes force by AC. I'm just considering this triangle AOC. So force is equal to force by AC is equal to mg, which is the vertical line in this triangle, OC. So that becomes mg by OC. Tension is along AC, so tension by AC. This is how you represent and write the forces. Whichever force is there, you will see the corresponding, um, you'll see the corresponding axis basically, or you can say side of the triangle. So force and then the corresponding axis. So force, so AC, mg, then OC, then tension, so OA. All right. So these now from this you can write down force as, let's just consider these two for our calculations. This is sufficient for our answer. So force will be equal to mg into AC divided by OC. All right, F is equal to mg into AC by OC. Now let's equate both the forces. This is one force which you are, this is second force which you are having. One force will be this is the first force. Equate both these, equate 1 and 2. So if you equate 1 and 2, you will notice that kq square by AB whole square, this is equal to mg into AC by OC. Now look here, AC is exactly equal to what? AC is just this part. This is L sine theta. If you take L is the length of the hypotenuse of the triangle. This is theta angle. So this part will become L sine theta. So double of it, this entire part is 2L sine theta. So it means if you put in the values, value of q square, this will become, this becomes AB square will become now 2L sine theta square will become 4L square sine square theta, right? K will get divided, so I'll write it as 4 pi epsilon naught. All right, what is left now? Mg L sine theta by L cos theta. So L getting cancelled. Cos sine theta by cos theta you get as tan theta. So Q square becomes equal to 4 mg L square sine square theta into tan theta. This is one of the tough questions which are available. So do practice it. If you have any doubt, let me know. I'll wait. Then we'll move on to the next question. So option will be option C. Q square is equal to 4 mg L square sine square theta tan theta into 4 pi epsilon. Note it down, class. Yes, Rifat, right answer. C class. How will we solve this? It says that 2 point charges are there. So only Rifat has tried. One charge is 2 into 10 to the power minus 7. Another one is simply 1 into 10 to the power minus 7 coulombs. Now they are 1 centimeter apart from each other. What is the magnitude of field produced by either charge at the site of the other? So E1 is equal to 9.8 into, these are options given. So let's just not read it directly. I'll tell you the solution. See, for E1, I'll write here E1 on one side and E2 on the other side. See, this will be equal to K Q1 by R square, right? K Q1 by R square, fine. So if you write the values of E1, K will be 9 into 10 to the power 9. Charge will be 2 into 10 to the power minus 7. And R will be 0.01 whole square. So E1, this will be equal to 1.8 into 10 to the power 7 Newton per Coulomb. Then you have E2. E2 will be simply, change will be there in just the value of charge Q2 by R square. So E2 will be equal to 9 into 10 to the power 9. Q2 is equal to 1 into 10 to the power minus 7 by R square is 0.01 whole square. So E2's value will be 9 into 10 to the power 6 Newton per Coulomb. So option number C. Option C is right. So Rifat could answer. Rifat Amna. See here, class, any answers? Or do you need 2 minutes? Or shall I discuss this? Let me discuss it only. See, it's a square that is kept. Just a second. How much you're getting, Hamza? Net answer is 27 into 10 to the power 10. I think it won't be 27. It would be 2.7. Just check. But I think you have solved it almost correctly. Just check. I think it's just 2.7. Once again, just check while I'm discussing it with the class. See, this is 50 coulomb. This is 50 coulomb. This is minus 50 coulomb. So this here you have A, at this point you have B, at this point you have C, and let's say this point is D point. So since this is 5 meter, this is 5 meter, it's a square, so all the separation will be 5 meter. This becomes root 50 meter if you apply proper Pythagoras theorem. Fine, this is root 50 meters. So electric field due to 1, first charge, that here it will be electric field 1. Electric field 2, because of second, it will be moving towards the negative charge. So this is E2. It will be moving away from the third charge. So E3, this is what you have. Now you have to find out the resultant. So here you had to first identify and analyze how the charges are kept, right? Now see electric field at B due to 50 coulomb. This we are finding out, no, electric field at B point. So see electric field 1, this will be K Q by R square, which is equal to K 50 divided by R is 5 over here, 5 square. So I'm writing this as K into 50 by 25. So that becomes 2K. So 2K along AB. Right? Now we are finding out for minus 50. Same thing it will come, I think. This is KQ square. KQ by R square, sorry, not Q square. KQ by R square. So K again 50 by 5 square, that will be 2K. That will be along BC. Fine. Now electric field at B due to 50 coulomb, that is kept at D. This root 1, this one, this separation, which is kept at D. Now see, this is root 50. So we will write E3. This will be K Q by root 50 whole square. That will be K into 50 into divided by 50. K into 50 divided by 50. That will be only K, which is along DB. Fine. This is along DB. So you have got all the three values. But now see, that is the value of E3. All the three values we have, but we have to resolve E3 also, no? This along X and Y component. So here, if this is theta, this is 45 degree, this becomes E3 cos 45 degree. And this becomes E3 sine 45 degrees. Now see here. So x-axis, if you find this along x-axis, look here class, E3 cos 45 degree, that will become E3 is K, cos 45 is 1 by root 2. So this becomes K by root 2. Fine. Now this is K by root 2. So if net EX, if you find out, this will be 2K plus 0 plus K by root 2. That will become K 2 plus 1 by root 2. Similarly, if you write about y-axis, EY is E3 sine 45 degrees. This is K into 1 by root 2, which will again be K by root 2 only. But this time the difference is that since E2 and E3 are acting in opposite direction, look here in the square. In this square, they acted in same direction, E1 and E3 cos 45. So we added. But here E3 sine 45 and E2, they are acting in opposite direction. So what we'll do, we'll subtract it. So here, if you subtract net EY, this will be 2K minus K by root 2. So this will be equal to K 2 minus 1 by root 2. Fine. Now you have to find out the resultant equation. Resultant electric field. So resultant electric field will be under root EX square plus EY square. Right, under root EX square plus EY square. So E will be, see, Ex is K 2 plus 1 by root 2 whole square, this term whole square, plus then K 2 minus 1 by root 2 whole square. This entire term within the root. So that will give you root 9k square or directly 3k. Now value of 3k, you already know. So yes, Hamza, your answer was right. It will be 27 only, or what? 3 into 9 into 10 to the power 9 is there. So that becomes 27 into 10 to the power 9. Look, Hamza, till here you were right. 27 into 10 to the power 9. You wrote 27 into 10 to the power 10. So if you're writing 10 to the power 10, then put 2.7 into 10 to the power 10. Fine, this much of Newton per coulomb. This is the resultant answer. Fine. Note down the solution. I hope, Hamza, you have understood, and rest others also. Is it clear or not?
Yes, teacher.
Okay. Note it down from this figure. Step by step solve it. Try to do it on your own. Wherever you're getting stuck, then look on the screen. First do it. First try it by yourself. Yes, class. So we have completed till electric field also. So now we'll do some questions on potentials and current electricity, Ohm's law and all also we'll see. Now in the next class on Tuesday, we'll see all these. Fine. Yes, one more thing, class. You have a test on Tuesday. Class test only because so many questions we have done, so many revision classes we had. So I want to check whether you have understood or you have practiced or not. So first book questions will be there from first book, because now there is no point of taking chapter wise. Already you are having your mock tests on Friday. Tomorrow also you will be having the mock tests number 7th, I think. So just be prepared with the first book, just revise. You are already studying every day for your examination, so it will be just a part of test. Fine. So I've just informed you all. I'll take a test on Tuesday. Okay, class. Thank you so much. Take care. Allah Hafiz.